Ladies and gentlemen, what questions do you have for me? Product and quotient rule, trig derivatives, chain rule. Talk to me. Yes.
You do
9 from 3.2? Nine from 3.2 is x over e to the x, right? Okay, so you have some choices in this problem. But I think the easiest thing to do, given what section we're in, is to say, I'm going to use the quotient rule. How's the quotient rule go? Perfect. Derivative of the top times the bottom minus, leave the top alone, derivative of the bottom. Do them one at a time, and then over the bottom squared. This is our top. This is our bottom. So our derivative of the top is okay. And the derivative of the bottom is, because the derivative of e to the x is e to the x. So y prime, derivative of the top times the bottom minus top times the derivative of the bottom over the bottom squared. Yes. Now, I happen to think there's a really easy simplification to do in this one. Everything on the top has an e to the x. I could factor it out and cancel with one of the e to the x's on the bottom. But you're right, that is an optional step. If all I ask for is what's the derivative, that's all you have to show me. Show me you can do the derivative and walk away. Now, given that we have learned some other things since this section, there are other ways to do this same derivative. But given where we are in the text at the point in time where you were asked this question, that's probably the easiest way to do it. You were going to ask about this or something else?
general concept. I like probably through the phone. Negative sign in front of the e, is that kind of a coefficient of -1?
Yes, because that's not just e to the x, that's e to the stuff. I need the chain rule. And that's why I didn't make the change here, because the other way I immediately thought of doing this was to take this y and rewrite it like that. A negative in front of an e, yes, that's a coefficient of -1. Yep. Or you could think of it as like I'm subtracting.
Like, I don't think you actually do that on this, but it had e to the e to the x. I don't know how to identify which is f and which is g.
So when I see that, my first reaction is to choke back the bile, but after that, that's e to the stuff, right? So I'm going to think of it as e to the stuff. There's the missing set of parentheses that tells me outside versus in. Because if it's e to the x, then it's really the e of, right? Like I think of sine of and cosine of and thing squared. Well, it's e to the thing. Well, now that's the bigger thing. So I can see that's either the messier thing than just an x. I'm going to need my chain rule outside versus inside. There is another notation for e. We can think of the exponential function like it was a sine or a cosine. Write it like that. Then I clearly have an argument, right? Something on the inside of my e. That would make that look cleaner, wouldn't it? Back in the crazy old days of low-level programming like BASIC and Fortran and COBOL, that was actually the way you wrote e to the x as a programming step rather than e shift 6 x. But that notation is older than all of you. Almost older than I am. More questions?
How are we supposed to go about 86?
86?
Yes. I can understand part A well enough. I don't like it, but I can understand it.
Okay.
I don't know how we're supposed to- For when velocity is so zero. But I don't understand how we're supposed to solve for it at zero, and you had so many variables.
You don't have so many variables. The best part about that problem is there's only one variable. Everything else is a number. The equation you're given is y equals a, is it sine or cosine? Cosine omega t plus d. This is a function of t only. A, omega, and delta are all constants. I didn't, not zero. That's it. That's all I care about. In terms of trig functions, here's a pullback from quite some time ago. I want you to think about, let's see, trig chapter, I think it's chapter 7, where we talked about sinusoids and harmonic motion. These all have representations when we graph sine and cosine. This is the amplitude. This represents part of the period. This represents the phase shift. Actually, I believe it is minus delta over omega, and it's 2 pi over omega here. And the amplitude is the absolute value of A. Amplitude is telling me how big my cosine curve is, top to bottom. Period is how fast it vibrates. And phase shift is, did we start, since it's cosine, it normally starts at 1 when t is 0, right? It would come down and go back up. Phase shift tells me how far I've moved that off of that starting point.
Just function, you have to include the plus 2 times.
But if you think about it, what is this asking? It's asking when the velocity is 0, right? Where is the derivative equal to 0? Think back to my demonstration. When is the velocity 0? When it stops and turns around. So what I'm asking you is, when does it stop and turn around? Tick, tock, tick, tock. That's all I want to know. I just don't give you any numbers in this problem, because then you can do it for any trig function with any values of A, omega, and D. Yes, ma'am. Yes, ma'am. The only variable in this problem is T. I'm pretty sure on the last trig class I gave, I asked a question that said, graph this function. What's the amplitude? What's the period? What's the phase shift? I think that actually had a vertical shift as well, but that's not relevant for this behavior. I know this is in that chapter in the trig book. But the whole purpose here is to say, what's going on as my pendulum is swinging back and forth? Or in this case, as a particle is moving back and forth. Because it does say the motion of a particle. Yes, ma'am. 28. 3, 4, 28. So do you want to look at 27 since it's basically the same idea? Okay. In 27, we have G of U. Really? Don't mess with me today. g of u equals big ugly thing in parentheses, u to the third minus 1 over u to the third plus 1, all raised to the 8th. The only difference between this problem and the problem you're asking me to do is that you've got a root, but I can convert a root to a power. So I'm going to do the outside of this as the power. The outside's the power, then I'm doing the power rule. Ugly to the 8th. The derivative is 8 ugly to the 7. So I'm going to start right away with 8 ugly to the 7. And the ugly doesn't change. Oh, it's a minus on top. It's a u cubed plus 1 on the bottom. Don't change the ugly. It's supposed to be the same. Now, chain rule. The derivative of the inside is rattling around in there. So I need the derivative of the ugly part. But that is a quotient rule. Because it's something over something. I'll do the quotient rule there. Derivative of the top. Leave the bottom alone. Then derivative of the bottom. Leave the top alone. Ran out of room inside my parentheses. I should know better than to close those suckers. All over the bottom squared. It doesn't say simple. I'm not simplify. I'm not going to. I'm not doing anything with it. I've done the derivative, walk away. You could do all sorts of algebra here. You could simplify by multiplying out and see what cancels. That should be a u cubed, not a u squared. There. Yes.
That would be the whole answer.
That's the whole answer.
Right.
This top is u cubed minus 1, bottom is u cubed plus 1, right? So t prime is 3u squared, b prime is 3u squared. Derivative of the top times the bottom, derivative of the bottom times the top. Subtract in between.
We're going to use the product rule many times in the form of like the f prime times g times a plus g prime and f times a.
I think I'd prefer to think of it as using the product rule recursively. Think of using t e to the t as one thing, and then cotangent t. Or think of t e to the t cotangent t. I'm going to do the product rule on those, but then when I go to do this, I need the product rule again.
Don't want to hit that.
Well, that would be what I get if I multiply out the version I'm doing. We haven't shown that the product rule works for those sorts of multiple behaviors yet. You'd have to prove that. Yikes.
Logic.
There's this wonderful problem. This looks like it should work, and then it does for a little bit. Then we try it for the next case, and it falls apart. This is hard. Not a good thing. We will show next semester in discrete math that the rules by which we make these rules have to be followed. I'm going to blame this thoroughly on Archimedes and the rest of the Greek geeks, Socrates and Plato and all these crazy philosophers. I can only use the rules I can verifiably prove. It should work that way, doesn't. As a matter of fact, the entirety of my PhD, the paper I wrote for my degree, is showing that a good assumption on the way a computer does something internally is wrong. And we lose valuable information in the computer when we do the calculation the way the computer does it. It's all about fractals if you're interested. Anyhow, I wandered way off course. More questions? Yes, ma'am.
Same section. It's the tangent squared.
The same section as yours or the same? Okay, so 3, 4, 32, tangent with the, okay, again, n is a variable. Perfect.
So I understand I could take the derivative of the outside.
And then I have to deal with the derivative of my inside, right? So now you're doing the derivative of, but that's not just tangent theta, is it? It's tangent of stuff. There's another layer hiding in there.
So then
And what would be the inside? Ta-da!
and so and that just be your constant.
Derivative of 6x is, n is a number. I don't know what number. It's just some number. Given that they're using n, it's probably a whole number, like 2 or 7 or -5, but that's just a convention that most geeks use. More questions? Yes, ma'am. Carry over to this other set of parentheses? No. They're all multiplied together, but the only part that's raised to the 7th is this. This is not raised to any power. But this result gets multiplied by this after we raise to the 7th, gets multiplied by the 8th. Do you mean carried over that way, or do you mean carried through like those operations apply? No, they only get put on that part. They don't get put on this part.
Like 18.
Which is t sine pi t. Well, let's look at 19. 19 looks disgusting, right? Again, this is, oh, wait a minute, I wrote it down wrong. F of t. The fact that it is written f of t means t is the only variable. A and b are numbers. So, e to number t sine of bt. I'm multiplying those things together. E to the at times sine of bt. So I need a product rule. Product rule says derivative first times the second. The second doesn't change. Plus first times the derivative of the second. First doesn't change. So these are going to be derivatives. This is going to be the derivative of this part. But that's e to the stuff. Up comes my chain rule. Derivative of e to the at. Derivative of e to the stuff is e to the stuff. So I get e to the at. But wait, there's more. The derivative of at, the derivative of number t, is just number. That number could be an ugly looking number, like pi. Over here, sine of bt, sine of stuff, derivative of sine, cosine. So the derivative of sine of stuff is cosine of stuff. Don't change that. But wait, there's more. The derivative of bt. Uh-huh. Yeah, my assumption is because of the way they've spaced it, this is another thing I hate the book doing. There's no parentheses around that, right? Is it sine of b times t? Or is it sine of bt? So I said the same thing, sine of bt. But where I put the pause tells me where the parentheses are. Textbooks should use more parentheses. There should be parentheses here, but they didn't put them down, and that pisses me off. This again goes back to being an old school programmer. There's no well-established order of operations, so you put parentheses everywhere. The calculator I used as an undergraduate did not work like the graphing calculator you have in front of you. You actually gave it the numbers and then told it what to do with them. So if I wanted to add 3 and 6, I'd say 3, enter, 6, plus. You put the operation at the end. It's called reverse Polish notation or postfix notation. You put the operation at the end. This is prefix notation. I'm going to do f to t. I told you what I'm going to do before I tell you what I'm going to do it to. The way we're doing it now is called midfix. I write 3 plus 6, it's in the middle. Postfix notation has no parentheses, ever. That made it actually a better programming tool. For those of you in computer science, that's called stack programming. You'll see it there in data structures. More questions? Yes, ma'am. 30. So, Angela, if I think of that as E of stuff, right? Then the inside part is the Z over Z minus 1. And that means that the inside derivative needs quotient rule. Now, that's not the only way to do it, but I think it's the easiest way to do it. But fortunately for me, my quotient rule here is fairly straightforward. What's the derivative of the top? 1, leave the bottom alone, minus derivative of the bottom times the top over the bottom squared. Advantage, when I multiply this out, that Z is going to cancel this Z. I'll just be left with a negative 1 on top. That step's not necessary unless I'm going to do something with it. That works better. More questions? This is not the answer. That is just to try and sleep with your eyes open and not snore. Yes, ma'am.
Show the quotient rule.
If my items are multiplied, I'm going to use the product rule, not the quotient rule.
On number 4 for 189 says in 2 ways values on the function and lesson to sugar and to salt.
Oh, so in problem 2 there, the simplification part is to do the algebra necessary to split up the fraction. So the fraction in question in number 2, number 4 just says differentiate. New instructions. That just says take the derivative. More questions. Yes, but it makes me twitchy. I prefer, if I'm going to use fractions in there, I'm going to stay in fractions, but especially if they're not terminating decimals, something like thirds or sevenths or something, I want to stay in fractions. Fifths, halves, quarters, you can use decimals. I'm not going to throw that big wobbly over it. Thomas.
Number 6.
3.4, number 6. I think 5 is fairly similar. Is that all right? All right. So in this problem, again, I put in the parentheses where they left them out. Theta squared sine theta. If you don't like thetas, feel free to change the letter. This is completely the same as h of t equals t squared sine t. Am I looking at the wrong section? 3.4, my apologies. 3.4. So we want to identify outside and inside.
There's number 6 still back.
In 3.4, number 6 is fine. So that's the cube root of e to the x plus 1, right?
Yes.
So what I want you to do is tell me which part's the inside, which part's the outside. Is which part? So if that's the inside, that's what we were calling u in class, right? But the textbook also calls that g of x. Because we're writing f of g of x, right? So then what's the outside part? Except it's a cube root, right? Cube root is stuff, yes? So I'm going to think of that now as an x, and we could write f of x is cube root of x, or we could write f of u is cube root of u, and so on, right? So there's a way to differentiate the two. And now it says take the derivative using the chain rule. So now it asks me to take the derivative, right?
Yes.
Derivative of the outside. What's the f prime?
Of the cube and stuff.
Yeah, this just this, right? Let's do it like it was just an x. Right? Perfect. Now, what's the derivative of g? Great. So now it's f prime of g of x times g prime of x. So instead of having an x here, I'm going to have that. 1/3 e to the x plus 1 is the negative 2/3. And then my g prime is e to the x. Now, again, you could simplify and say this has a negative power, so it should go on the bottom. And it should be a root of, so I don't care about that. Better? Yes, Paul.
Would be, and should I view that as T being one value, E to T being another one times those tangent being another one?
Yes, but I don't know how to deal with 3 of them. So I'm going to group 2 of them together. Pick 2.
So T
Put parentheses around those. And then you've got thing times thing, right? That's the product rule. But then when I go to do the stuff in parentheses, I need the product rule inside the product rule. Pimp my function. I heard you like product rules, so we put some product rule in your product rule. $40. So say it a little louder. It should have 1 right there. In a local neighborhood, it should only have 1. But as we go out, yes, we can cross the curve more and more. So let's consider that curve is called a serpentine, right? Because it wiggles back and forth like a snake. So if I draw that curve even badly, and we pick a spot over here on the right, because we have like x equals 3 or something. If I draw a tangent line here, well, then it's probably going to cross back there, isn't it? Our tangent lines can cross the curve in lots of different places. Let's think about a different looking curve. Let's think about a cubic equation, right? So here is some cubic equation. If I draw a tangent line here, it's going to be above the curve, right? But that means here. What happens as I keep going off to the right here? Way down there. But that's so far away that really, because we're thinking about our limit is a local behavior. I can go you one crazier. At 0, the tangent line actually crosses the curve. It only touches it in one spot, but it actually crosses completely. It's above on the left and below on the right because the curve bends on both sides. And that bend causes the tangent line to cross over. But still, in that neighborhood, the line is going almost exactly the same way the curve is going. We'll actually figure out why that does that in chapter 4. More questions? Yes. Uh-huh.
And then five.
I want you to identify which piece is inside and which piece is outside. That's the composite form, right? F of G. So F is the outside part. G is my inside part. I've labeled them appropriately, haven't I? Then I do the derivative of each part. And the chain rule says put G in here. Yeah, it just wants you to write out all the bits rather than just do the derivative. Emily, I think you were the one who asked me, I don't have to show the substitution part. This is the one example where they want to see it. One of the biggest issues in using the chain rule is making sure I know which is the inside and which is the outside. And thus recognizing cases where I have more than one layer involved. More questions? Talk to me.
You can check to see if your tangent line equation's correct. So I got some weird numbers from you.
My best bet is to graph it and compare the curve and the tangent line and to see if I'm really seeing something that kind of goes in the right direction. Because if I see something that goes like this, I know I've done something wrong. A tangent line should be going roughly the same direction as my curve from left to right. A line that sticks out at a weird angle screwed something up. The only other way I can check this stuff is to get on something like Wolfram Alpha or Desmos and say, hey, do this derivative for me and find me the tangent line. I don't recommend it, but yes, you can check your work, but it's easier just to graph and see. You might have to look at a very close-up scale to see how close they are. More questions? Jordan, please don't strangle the phone. More questions. Come on, people, talk to me. Y'all got this. It is important to notice that in every one of these problems, in all of them, we are doing something the same everywhere. And that is our equations are all written out, y equals, f of x equals. What happens when they're not? This is actually an original question because function notation, the way we use it, is more recent than the development of calculus. Function notation comes around in the 1800s. Calculus is 60 years before that. So what happens if I can't separate my equations the way we like? That's what we're going to do on Monday. So this stuff, you need to get down. I will see you all then. Have a wonderful weekend, people. And if you've got questions, send me emails. I know, write it down. There's 10 minutes left. I'm giving you a benefit because it's Friday. And I have to get off campus anyway.